topic for this term is differentiation. And we're first going to look at limits. Now, limits has a specific notation. And the notation, if you write it in an exam question or exam paper, must be correct. Otherwise, I subtract 1 mark for wrong notations. It looks like this. The limit when x tends to 1 of the following sum. So this bottom part means x approaches 1, x tends to 1 of x plus 1. Now what does this mean? Let's quickly look at what it means. Yeah, man. If we have a number line and 1 is in the middle, that one. The number just above 1 will be 1, 009, and a little bit further you'll get 1, 09, and a little bit further you'll get 1, 1. What happens if x approaches 1? What will the answer be? So let's substitute these answers. Values 1, 1 plus 1 gives you 2, 1, 09 plus 1 gives you 2, 09. 1, 009 plus 1 gives you 2, 009. So what do you see? To which value does this one go? To which one? It tends to go to 2. Let's look at values less than 1. Just below 1 you get 0, 9, and then further down 0, 009, and further down 0, 009. If I substitute these values in my sum, I will get 0, 9 plus 1, which is 1, 9. 0, 009 plus 1 is 1, 009. 0, 009 plus 1 is 1, 009. So, if I go near 1 on this side, can you see that the values also tends to go towards 2? So, this sum asks you, if I take the value of x and it approaches 1, what will actually happen to my answer? It will tend to go to 2. So this will be 2. So that's what this notation and this sum means. Let's look at an example. Example 1. What is the limit if x tends to 1 of x plus 4? Now what is important in your notation, if you have a sum after the notation and it has more than one term, that sum must be in brackets. So if there are 2 or more terms, you have to use brackets. The other thing that's important is as soon as you substitute this value into your sum, the notation part disappears. Okay, I will show you what that means. The first thing that you do when you get a limit sum is you have to look at your sum. Now look and think. If I substitute this 1 into the x there, will there be an error on the calculator? Yes or no? No. If you have an answer of no, then you can substitute. So, and as soon as you substitute, you lose the notation. So I'm going to substitute now. It will be 1 plus 4, which is 5. So as soon as you substitute, then you don't write the notation. If you do the following in a test, you'll get no marks. This is wrong. 0 marks. Okay. As soon as you substitute the value, you lose the notation. Okay, let's look at another question. What is the limit of 2x squared minus 4x minus 6 over x minus 3 if x tends to 3? Step number 1, look. Will I get an error if I substitute 3 into the x's? Why? Yes, I will get an error because then I will divide by 0. So if you see that you will get an error, you make plan B. And what is plan B? Factors. Am I going to substitute the 3 into the sum at this stage? No. Can I lose my notation? No. So I still have to write it. Lim x tends to 3. And how can I factorize that? Take out a 2. Good. X squared minus 2x minus 3 over x minus 3. Now you look again. If I substitute the 3 into the denominator, will I get an error? Yes. What's plan B? Factorize. So I still need to factorize again. What can I factorize now? The bracket, the trinomial. Okay. Am I going to substitute the 3 in? No. Must I still write the notation? Yes. Lim x tends to 3, 2 over x minus 3. Okay, if I factorize the trinomial, x squared is x times x. The 3 is 3 times 1. It's negative 2x, so it must be minus 3x plus 1. And now you look again. Is there something that can cancel out? Oh, yippee. Those can cancel out. Now you just rewrite the new sum with everything that's left. Look again. If I substitute the 3, will I get an error? No. So can I substitute the 3? Yes. What can I do now? Take out the notation. So this will be 2, 3 plus 1. 3 plus 1 is 4 times 2 is 8. Very easy.
So if you enter each sum, you have to substitute what is equal to it.
So at the end you have to?
Substitute what is equal to.
Yes. Yes. Now the next question is, what will happen if we have a limit sum and we have infinite limits? There are 2 rules. Rule 1 is the limit where x tends to infinity of 3 over x. Now I'm just first going to explain how we get our answer for this one. If you look at the sum part, what type of function is that? Is that a straight line? What? Exponential? Hyperbola. It's a hyperbola. So, at the x, there's a plus 0, and at the end, there's also a plus 0. So, my limit, my asymptotes, will be on the axis. This one is x is 0, this one is y is 0. And my hyperbola looks like this and this. What this sum means, if x goes on into infinity, so at the beginning x is big or small, and then x goes on and on and on and on and on and on and on into infinity, what will happen to the y value? It will grow nearer to 0. So that's why if you have an hyperbola type of sum, your answer will be 0 for infinite limits. Are you all with me? Okay. Let's look at rule 2. The limit of 3 to the power of x, x tends to infinity. What type of function is this? Exponential. And we have a plus 0, so my asymptote is y equals 0. If x tends to go to infinity, so here it goes up and up and up and up and up, x goes that way into infinity, what will happen to the y value? Where will it stop? So it also goes into infinity. Therefore, if x goes into infinity and you have an exponential kind of function there, your answer will be infinite. Now let's do a sum with the limit where x tends to infinity of 2x plus 3 over 5x minus 4. What's the first thing that you always do with limit sums? You look. Okay. If I substitute the infinity into x, you'll have 2 times infinity, which is infinity. Add 3 to that will give you infinity again. If I substitute infinity into x in the denominator, 5 times infinity is infinity. Subtract 4 is infinity. Oops. What is infinity divided by infinity? Nobody knows. So now we do plan C. We already used plan B. Plan C says, if you have a limit, I don't know why he's doing this. If you have a limit where x tends to infinity, and you see that you're going to get infinity over infinity, you take the variable. What is the variable in this sum? X. And you take the highest power of this x. What is that? 1. And now I'm going to divide each term in the numerator and in the denominator with x to the power of 1. Okay, let's see what happens. So I take the 2x and I divide it by x. I take the 3 and I divide it by x. I take the 5x and divide it by x. And I take the 4 minus 4 and divide it by x. Now you divide. So these cancels out, and then you get 2 plus 3 over x over 5 minus 4 over x. Okay. What type of function is that? Hyperbola. If x tends to infinity in hyperbola, what will I get? 0. Yes. The same for the bottom fraction. So now I have 2 plus a 0 and 5 minus a 0. I haven't substituted anything yet, so my notation stays there. Now if you work it out, you'll get 2 over 5 with x tending to infinity. There is no x, so my answer will be 2 over 5. Why the frown? Are you with me? Good. Sometimes yes, but in this case not. Let's look at another example. This is only one that I sucked out of my thumb. I just wanted to show you, if you have a variable and you have a higher power, x to the power of 3. Now each term in the numerator and the denominator will be divided by x to the power of 3. Okay. This won't work out because I will get 0 minus 0 and divide by 0 gives you error. So just stop there. This is just to show you that if you have a higher power, you choose the highest power to divide with. Any questions up until here? Stop. want you to quickly page to page 5. Sum number K. There's a mistake on the printout. That x squared must be x to the power of 3. The lesson of today was only page 1. So your homework will be exercise 1, starting on page 2, exercise 2, starting on page 4, up until number T on page 7. Now I have a rule in my maths class. If you complain about having to do homework on a Friday or over a weekend, I give you more. If you complain about how much the homework is, I give you more. So are you happy?